So tonight we are going to be working with database design. We are also going to learn how to make our entity relationship diagram, our ERD, which is basically a way of designing our database before we actually make all of the tables for it. So if you thought SQL in 2 nights was fast, wait until we do database design in 1 night because, again, this is usually a semester-long kind of class that they teach. The good news is just like SQL and me only using, I don't know, a quarter of what I have learned in courses on day-to-day actual work, database design is largely the same thing. So you guys have a homework assignment for this weekend to make your entity relationship diagram for your capstones. Obviously, you can't do that right now because you don't know what an ERD is or the rules of database design. So I have put a link in the chat to the slides for tonight. I will throw it in there one more time in case anyone joined late. Those are the slides that we are going to go through, and they are largely based off of this article that I also linked in the Slack chat. So this is a kind of long article, but these cover basically all of the rules of database design. So if you are able to follow this document, you're really able to design any database. The challenge of this is there are a lot of little rules that get tricky when you actually go to apply them into your database design. So I'm going to go through these. I'm going to talk through these. This is one of those classes that absolutely needs your feedback, right? So if I'm covering a topic and all of a sudden you catch yourself like zoning out and you're like, I don't understand what he's talking about, or those words make sense in a sentence, but they don't make sense in terms of how I would actually apply that, definitely throw a lot of questions in the chat or raise your hand in Zoom, because it's just so easy to kind of gloss over and then realize that the content isn't actually soaking in. So this is definitely feel encouraged to get involved here, ask questions. After we do this, we are going to switch over to a chart software called Lucidchart. Actually, we're going to use diagrams.net. They're based off of the same code base. So we're going to learn a software specifically for making a diagram. Kind of like we used Figma for learning how to design a UI. We're going to use Lucidchart for making your ERD. I'm sorry, diagrams.net, I think it's called now. But whatever tool you would like to use, if you do have experience or practice using another diagramming tool, you are welcome to use that instead of diagrams.net. For the homework assignment, diagrams.net is just what we're going to cover tonight. So before we dive into any of that, does anyone have questions? Oh, it's now drawio.com. They keep on renaming this stupid thing. Anyway. Any questions about database design or about the SQL exercises before we get started? Okay, let's go ahead and dive on into this. So starting with some basic terminology, right? Table, obviously very important. Table are rows and columns. Think of it as a spreadsheet. And this is one of the most useful tips that I finally understood as a teacher that makes it click for you guys, right? So when we're designing a database, oftentimes we're looking at the columns, but it isn't really clear how those columns all will work and look at the end of the day. And so sometimes it's really helpful to open up Google Sheets or Excel and start putting those columns across the table, right? Put them in the top row and start loading the data up, because oftentimes we can start to identify, oh, wait, it turns out that I'm storing this password over and over and over again because I have started loading that table up with dummy data. So we're going to see that in a little in a little bit, but there may be a few columns in a table. There are an unlimited number of rows in a table. Databases scale up really well with number of rows. They are more limited in the number of columns that you can have. And most databases will have more than one table. You may hear a column referred to as a field. A field is basically a column with a name and a very specific data type. So just like we have data types in JavaScript, like strings and booleans and numbers and stuff like that, we also have data types in our database. And then every row will represent a single item in the table. So in a table called products, each row would be a product. Every product would have a set of fields. Those fields would have specific data types. Things like product name, cost, number in stock, all of that kind of stuff. Okay, so good database design divides your information into subject-based tables to reduce redundant data. What do we mean by that? Well, it makes sense if we have a customers table and an orders table. If we tried to store all of that information in just the orders table, every time a customer placed an order, we would have to store their first name and their last name every time they made an order. Well, that's not particularly efficient. What would make more sense is to split that in two tables and have our order store a customer ID that's referring to a foreign key in the customers table, which would be the primary key. We're going to learn about keys in a second. Basically, the good database design is providing the information it requires to join those tables together. So just like we learned about left joins and inner joins last night, we are basically setting up our table structures so that they're really optimized for joins. We want to make sure that the information is accurate and that the integrity is together, right? What do we mean by that? We mean that we can't accidentally update the database in one place and then have inaccurate information we forgot to update in another. So if we've designed the database well, we will only have to update the information in one place and not have to update it in multiple places. And then finally, it's really important for data processing and reporting, right? What you don't want to do is have your boss come to you a month after the product's launched and say, hey, how many people signed up for a new account? And you're like, I don't know. I just know how many people placed an order. And your boss may go, no, we need to know how many people placed recurring orders or how many people came back and placed a second order. Well, if all you're doing is keeping track of orders and not the customers themselves, now all of a sudden your database is poorly designed because you're not capturing all of the information. So all reasons of why we need database design in the first place. Any questions?
Yeah, I got a question. So a person who creates database, they're a software developer. Do
They could be, yeah.
do data analysts also create database, or they just analyze the data?
Yes. So it depends, right? A data analyst could get an export from a software engineer, and the data analyst could create their own database, import the data, and then use SQL to analyze it. They may share a database, right? They may say, oh, the software developer set this up, or the DevOps person set this up. The application developer is responsible for inserting all of the data into the database, but now it's my job to look at the millions of rows in the database and actually turn that into something usable. And so a data analyst's job is to turn what we call data into information. So what's the difference between the two? Data is just a row in the database, right? It may have information in it, but what the difference between data and information is information is actionable, right? It's telling us something. The data may be 50 rows of orders, but the information would be 48 of these 50 orders have been placed with a shipping address in New York, right? And so that's the data analyst's job, is to convert just what we would consider variables or just information in the table into something usable. So a data analyst could very well say, hey, I have this CSV of 1 million rows. Now I need to import that in a database so I can actually write some commands against it. So lots of people could create a database, but it tends to usually be either a developer or an administrator who's doing that. And then there are a lot of people who could overlap and use that as well. So I worked at AOL as one of my first internships, and I wasn't allowed to touch the database. They said, here's an export of the database. You can use this copy of the database locally, but if you need any changes made to the database, you have to go to a database administrator and they will think through the impact of changing a table or creating a new table, make sure that the design is correct, and then they will make those changes for you. So that's not a data analyst or a programmer. I was responsible for filling those fields that the administrator created for me, but it wasn't my responsibility to design the database or make changes to it. All I had to do is say, I need to store this additional data. Tell me where you're putting that column, and I will update that column in my code.
Okay. Thank you.
Great question. Any other questions? And this really boils down to, well, how big of a company are you working in, right? If you're working in a company the size of AOL, they had an entire team that was responsible for setting up, administering the databases, and designing them. If you're working at a startup or doing contract work, you don't have the benefit of having a database administrator, right? So it is up to you to do the design and sometimes even pay the consequences when the design isn't done right. So just depends on what kind of project you're working on and how big the company is. Okay. So, what are the steps of designing a database? Well, first of all, we need to have a purpose of the database. We're not going to just spin up a database because we think we may need one. You want to kind of have a mission statement of that database. Why do we need the database in the first place? It's going to obviously help us find and organize the information we need. Notice that says information and not data. Data is what we store. Information is the process of coming up with something useful from that data. We need to divide the information out into tables. We need to turn information into columns, right? So just because we have an address doesn't mean that we're going to throw that in as one column and call it a day. It makes a lot more sense to instead store address line 1, address line 2, city, state, zip code. Well, why do we break those out into 5 separate fields? Because if I say, hey, tell me all of the orders placed in New York, well, what happens if someone typed in NY or spelled out New York? If we're able to put that data in one column, it becomes much easier to work with it compared to one really long string, which the user may have left out their state. So we want to divide that information into columns. We're going to specify primary keys. 99% of the time, the primary key that we're going to use is an ID that the database generates for us. Then we're going to set up table relationships. That is how we do our joins, basically. We are going to store a foreign key into a table, and then we are going to have that foreign key be linked to the primary key in another table. We'll see how that works in a second. We need to refine our design, right? Because oftentimes we think we're done with the design, then we go back in and do a revision, and it turns out that we ended up duplicating data, or maybe we need to shift some things around, right? So the first draft is not always going to be the final version. And then we need to apply normalization rules, which you guys have no idea what those are yet. We will get to those in 1 second. I'm going to throw the link for these slides in Slack, just in case you are joining late. Okay, so determining the purpose, it's a good idea to write that down in a sentence. It sounds like a really easy step, but oftentimes it's a good idea to anchor yourself while you're designing it. You need to figure out who's going to be using that database, right? It may just be you through your application, but you want to think about those end users. If you have multiple role types, oftentimes that will impact how we design our database. What do we mean by role types? Well, there may be an administrator who's allowed to create new posts, but then there may be a user who's only allowed to create new comments, right? Well, we want to think about that in our database design because that may impact it. And then defining the mission statement will help the design process to focus on your goals and make decisions. So how do we find and organize the info? Start with existing information, right? Start with a spreadsheet with some dummy data inserted into it, right? And this is great for your capstones. Chances are you aren't starting from scratch. There is some data that exists somewhere that you can use, and that isn't always digital, right? So if you think about this as creating we're going to use the use case of a appliance repair shop. So we need to think through, all right, they don't have a database. They're not digitized at all right now. Where is the data living that they're running their business off of? Well, that may be a paper form that they're filling out still, right? I know there are some dry cleaners that are still running on paper tickets, right? And so oftentimes you can use that as a starting place to figure out what kind of data you need to capture and design. You also want to think about the business process. Oftentimes, businesses run on processes that aren't documented at all. So we want to think about, hey, what's the process of dropping off an appliance to be repaired? Well, they're going to go up to the front desk. They're going to ask certain questions. They're going to get your address. They're going to fill it out on a form. They're going to tape the form to the appliance that you're dropping off, all of that kind of stuff. So you want to kind of think through, all right, what is the process, whether that's a process of the user clicks on this and this in my interface, or that process is something that they use in the actual business. Don't worry about getting it perfect. We can always modify the design as we go. It is much easier to get the table right on the first time around, but it is possible to do alter table commands and to write some SQL to move data from one table to another. Consider not only what the data is being stored, but what is the output, right? So is this going to be a website that's going to show the information? How does that get laid out? Is there going to be a map on that page? Is there some kind of report, right? Are we going to generate out a PDF with all of this information in it? If so, how does that change? And then break down information as much as possible. We don't want to store just name. We want to store it in two separate fields, first name, last name, and maybe even title, because it becomes much easier if we go to write an email now to our customer and want to say, Dear Max. Well, if it's just the first name stored in the database and we made the user enter their name in two separate fields, we're able to know where that's split. There are all kinds of issues that you run into where you go, oh, well, just split it the first time that you see a space. Well, what happens if your first name has a space in it? Or what happens if your last name has a space in it? Now, how do we know where your first name starts and your last name ends, right? Or other way around, your first name ends and your last name starts. So break information down in your database as small as possible into those different fields. It is much easier to combine data. We actually already know how to do that, right? We concatenate in JavaScript. Much easier to combine data than it is to break it apart. Pausing there. Questions? Terry.
Is there like a limit of like for example, if like a username, if it like one like user have like a really long like name, like is there like a limit of like the database able like to hold that information?
Very good question. So it varies per database SQL variation that we're using, basically. So in Postgres, which will be the database that we use from here on out, there are well, there are probably more than two, but I'm going to say two for now. There are two types of strings that we can use in the database. One is called a varchar, which stands for variable character. And that can only have a length of up to 255 characters. So for a username, that usually is enough, right? Because it makes sense to tell a user, hey, if you're making a username that's more than 255 characters, you don't, your username's too long, make it shorter, right? Um, for However, there are also times that we obviously want more than 255 characters, right? The first major project we'll do in the database, other than the to-do list, which we'll probably do tomorrow, we need to need to store more text than 255 characters, right? When we're making a blog post could be paragraphs and paragraphs long. And so in that case, we use something called text, T-E-X-T, instead of the varchar, which has a near unlimited length that we can store in it. Obviously, that is constrained by how big the hard drive is and how much the database can, write to, basically. So by default, when we do our database design, we want to use varchars on anything that is going to be more of a sentence or a short snippet of text. And then we use the text instead of the varchar when it is basically something that the user could write a very long section into. The varchar is much more efficient for the database because it's not allocating an unlimited amount of storage for that text. But there are obviously cases like the blog post content that we would want to use a text for because we want to be more than 255 characters.
Also, I'm sorry, I had
Nope, go
like
ahead.
another question. Is it also possible to add like an image or like a video or like an audio file inside of those databases for you to like to pull?
Yeah. Very, very complex answer there. Historically, it has been advised to not store large files or any files really in the database. So traditional database design says, hey, don't store it in the database. Instead, store it on a file system, right? So store it in Finder or store it somewhere outside of the database. And then when you do store it there, take the path to that file and store the path in the database instead of the file itself. Databases are more efficient at storing little pieces of content or data, right? Whether it's really any data type. They aren't efficient at storing larger things. And so the traditional advice has been store the path in the database instead, and then use the file system to basically store a copy of that file. That gets a little bit more complex when we are trying to deploy, basically get the code off our computer and up onto the cloud, because now we need a copy of that file stored in a file path. And then that gets even more complicated when you add in something like a CDN, a content delivery network, which is basically making those files accessible across multiple servers on the internet. So that is a very complicated answer. Once we get into full stack, we will try and do an example where we upload a file and we store that file into the database. And that's fine for kind of a minimum viable product. That's fine for getting your capstones up and running. But at a certain point, you would want to look into scaling your application and not storing the files in the database, storing them in a file path and using the path instead. Any other questions, Terry, before I move on to the two in the chat?
Probably like one more because I ran it down. Like, is it possible to like add like I guess a Boolean like to the table? So if you pull like something like, oh well, if this person in here, yes or no, you know. Like,
Yes, it definitely is. I'm going to share this link. That's the list of all the, oh, well, I don't like that it put me on V7. I don't know if we're going to use V7 or V6 yet. Yeah, that's not stable. Let me take that link out. So this is the list of all the data types that we'll be using. Don't worry too much about like the differences between them. I really wish they provided a so anyway, you can see here if we do a string, it will default to a varchar 255, which is 255 characters long. You can see that the text is what I was talking about. That's like the unlimited amount. Booleans, really easy, right? Is it true or is it false? We have numbers in here. We will use an integer for any whole number, and then we will use a float for any decimal number. There's something called unsigned and zero fill. An unsigned number basically means that instead of the number only being able to go up to 32 million, something around there, you can make it say, hey, this number will never be negative. And because of that, you can then go up to like 64 million or billion in terms of how many digits can be in there. Obviously, not a big deal. There's a date, and then there's also this date will also store time with it, or you can use a date only if you don't want the time stored with the date. For example, if you had a to-do list item and you said, oh, it just needs to be done by this day, it doesn't necessarily need to be done by a time. Excuse me, you could do a date only. These are the core data types. There are a couple others in there, but hopefully this gives you an idea of how to get started and what data types are available to you. Okay. Um, okay, now there are 3 other questions in the chat. What about user password? How should it be stored and how do we make it safe? Very good question. There is something called password hashing. And a hash is a one-way encryption algorithm. We typically use bcrypt in class, which is the name of the library and also the NPM package. That basically allows you to store the database, store the password into the database encrypted, and secure in a way that you don't know, you can't decrypt it. All you can do is take the password that a user has entered, hash that password, and then compare the hash result to what's stored in the database, which is also the hash, to see if the password is a match or not. That is what they call rolling your own authentication or building your own authentication system using using someone else's encryption algorithm, in this case bcrypt. However, there are security vulnerabilities that come with hashing your own password or storing the password at all. And so we will be teaching a library called Clerk, CLERK, that allows you to build authentication into your application without being responsible for storing the password yourself. So Ryan will be coming in. Where did it go? Ryan will be coming in August 27th and 28th to teach authentication. So I would say hold off on that. You can, for now, just in your users table, keep like a username and a password as like a placeholder. Obviously, this is all dummy data. It's not going out on the internet. It's not getting deployed. So it's not a big deal to have a username and password, but he will be going over how to integrate Clerk not only into your API, but also into your front end and saving the user data based off of who's signed in, basically. So we'll be using Clerk instead. But the answer to your question, and if we have enough time in either a review week or in the full stack weeks, I can show you an example of hashing and how we can store a password securely in our own database without using a third-party service like Clerk. I oddly find building authentication flows fun, but they can get a little complicated. Is that why most text-based applications, early message apps, and Twitter were limited to a character count, or did it have to do more with packet size? Actually, neither. It had to do with an SMS limit. So SMS is what simple messaging service is what text messaging had been based on, and on iPhone is still based on until iOS 18 comes out, and they are replacing SMS with RCS, which is Rich Communication Service. SMS has a limit of 160 characters. And so because Twitter was initially very widely used on SMS right before the smartphone days, a lot of people would like tweet by sending a text message to Twitter, and Twitter would have that phone number linked to your account and post that tweet based off of what you text the Twitter phone number, basically. And so that's why they were limited to SMS is 160 characters. There's some Twitter for a while was 140, and then they changed their limits, and now that's mostly gone. So databases are usually limited to 255 characters because 256 is a round number in bits. And then there's some weird, you have to account for null or something. So that's why it's 255. So Twitter and early messaging apps is more an SMS limit, which was 160 characters. I don't know where 160 came from. That may be an arbitrary number, but you will find a lot of web applications today will limit your text input to 255 characters, unless it is a section that is obviously meant to go over that, and then they will change it from a varchar to a text blob. Not to do anything with packet size that I'm familiar with, unless it was packet size on the like network carrier and transmitting it, and
That's what
a
I meant.
possibility.
Like the SMS packet for carrier transmissions.
Yeah. That goes over my head. But it was not a database limitation. It was a SMS cross carrier agreement kind of thing. Do DB applications infrastructure list their natural limits, max storage limit anywhere, or is there a way we can check dev type using an external tool?
You actually answered that when you pulled up the documentation for that. I mean, is it pretty standard that all of those tools have those documentations on there?
Yes.
Mainstream applications, I mean.
Yeah. And databases, specific fields may have limits, but there are tons of databases now that are operating on exabytes worth of data, which is, the step after terabyte, which is a step after gigabyte, which is a step after megabyte. So there are basically, if you have enough money, there is a way to make the database larger, right? There's something called horizontal scaling and vertical scaling. I will try and not go too far down a rabbit hole on this because this is a DevOps concept. But vertical scaling is basically saying I've got one database server and it's sitting on one CPU and it's got a gig of RAM. So you can vertically scale by saying, oh, I'm going to give it 2 CPUs and 2 gig of RAM, all the way up to like 128 gigs of RAM. Some may support 256 now. Obviously, that gets very expensive, and you're going to have a almost $100,000 server bill once you get up to that level, which is very common at larger companies. So vertical scaling is just keep on throwing more resources at one server. Horizontal scaling is saying, hey, I need to break this server up into multiple servers, and then those multiple servers can share the load. Oh, I forgot about petabyte. So there horizontal scaling is much harder to do in a database, and not anything you guys will be expected to do for your capstones. But when you get into horizontal scaling, you get benefits like redundancy and being able to have your database across multiple regions for reliability. So lots of stuff that you can do there. But it is good to know vertical scaling means basically keep on adding more to that one server, keep on making that one server bigger. And then horizontal scaling is the notion of spreading that load across multiple different servers that, can share the resources. Okay. Any other questions or any questions that I didn't answer in its entirety? Okay. Okay. So now we got to divide the information into tables, right? So the best way to do this is say, all right, I'm going to just come up with all of my table names. I'm not going to necessarily think about what goes in those tables yet. I'm just going to think about what is the core idea of my app. And all I'm going to do is just write all of those down, right? So I'm going to start for this. This is a company that runs a warehouse, right? And you can place orders with the warehouse. So I need to break that down, and I say, all right, I'm going to have customers, I have suppliers, I have products that the suppliers give me, and then I have orders that the customers place. You notice that this is not a database design. All we're starting to do here is capture all of the information that we may have to store. Then we start breaking that down and saying, okay, products and supplies are in the same table. You would duplicate information about the supplier on every product row. So if I'm saying, hey, the supplier who gives me my microphone for class also is the same supplier that gives me the cable to plug that microphone in. Well, if I stored the supplier name in my products table, now all of a sudden I'm storing their name over and over for every product that they supply me. We don't want to do that. So that's how we start to identify, hey, I need to separate them out into 2 separate tables. What other consequence of duplicated stored data do we run into? Well, the other problem with storing duplicated data is, one, that the data size of it, right? Now we're storing more in the database than we need to. But 2, the other problem is what happens when we go to update that. We may update that on one row, not on all the other rows. And now how do we know what the correct row is? We also can run into problems in what happens if we put the supplier's information in the products table. We then secure a relationship with a supplier, but we don't know any of their products yet. Well, then how do we store that information in the database? We can't make a new row for a product and store the supplier information in if they don't have any products. So we run into a problem there of, all right, that's another reason we want to split their information out into another table. Store information in the table that the fact data is about. I have no idea what I meant by that last bullet point. Oh, I guess you don't want to store information in the table unless it is specifically related to that table's name, right? So for something like products, we wouldn't want to store something in like uh we wouldn't want to store something in there like city, state, zip, because we would want that obviously to be part of either the supplier's table or the customer's table. I think that's just common sense. I have no idea why I felt the need to move that into another bullet point. Okay. Any questions on dividing things out? We will get some practice with this in a second. Okay. So how do we identify columns? Start with the initial list and refine it down. If you think things should be split into individual columns, address is obviously the easiest example there. Don't store any calculated data. What do we mean by that? Well, let's say that the customer is placing an order and that order has 3 products in it. It may be tempting in the orders table to say order total is equal to and however much that order was. But what happens if the products change down the road? What happens if the cost of those items change down the road? Usually we want to not store anything that could be calculated. So if we are storing the products that are part of an order, what we want to do instead is calculate the total of that order by adding up the individual price of all of those items. So in general, we don't store calculated data, and that's going to tie into the rules of normalization in a second. And then store info in the smallest logical parts, right? So breaking down name into first name, last name, title, that kind of stuff. Okay, primary keys. Every table in SQL should have a primary key. In SQL, we usually do that by adding the tag auto increment, which will basically tell the database, hey, go look at whatever the last ID was and then add 1 to that. It is not a requirement that every table have a primary key, but it is a strong recommendation that you do it. And just a good habit to say, hey, whatever I create a table, I'm going to create a column called ID and basically set it to auto increment. It is possible to use other columns as primary keys. However, we don't normally do that because it's so easy to have the database make up a primary key for us. That is a number that just gets generated. Sometimes you can identify an already existing piece of data. For example, a product ID may already exist that you can use as a primary key. So some data may have like a UPC code on it that would make it unique. Like a barcode ID on it, basically. So you could use that as a primary key, but in general, good idea to let the database generate it. And then primary keys can never be duplicated, right? So you want to make sure, hey, I don't have 2 products with the exact same barcode on it if I am making that my primary key. Terry.
So it is a good practice to always like put like ID in your tables.
Correct.
Okay. And also, do we have to like? Well, I know we don't have to do this, but would you will it be okay to like for us to like I guess like I'm trying to like use like Google like spreadsheet. I'm like I don't know how to work this. So I was like wondering if it's like be okay to like I guess put like our like data that we need for our capstones into the spreadsheet, and then once we get settled with like setting up the database and stuff, then moving that data into the actual like database.
Yep, that's totally fine to do.
Okay.
Okay. Okay, that's everything for there. Table relations. Thinking through what tables relate to each other may impact our database design, right? So the primary key is what we just talked about. That's the ID. Put 1 in every table, set it to auto increment, you're good to go. The foreign key is just a column that stores the primary key from another table to relate the rows together, right? So we started to see this with the friends table. We said in the Khan Academy code, we had friend 1 ID, friend 2 ID. We were able to link that data back together. So in this case, if you had a customer who placed an order on the order table, you would add a column called customer ID. It would be a foreign key in the orders table, but then in the customers table, it would be the primary key of ID that we basically link that to. Okay, so let's talk about table relations. There is one relation called a one-to-many table type, right? And this is basically saying one teacher can have multiple students. So the primary key is the teacher's ID right here. The foreign key is the teacher ID in the students table. So we are able to say, hey, because student 1 and 2 both have a teacher ID of 1, we are then able to do a join on our table and say join the teacher's table to the students table, where the teacher's ID is equal to the students.teacher ID. When we execute that SQL statement, we are then able to get the information that Nate and Edna have me as their teacher. So a one-to-many table or a one-to-many table relationship is just saying one teacher can have many students. Many-to-many tables get a little bit more complicated. So let's think about products and orders. A single order can have many products. One product may be included in many orders. That means we now have a many-to-many relationship because many orders could have many products in them, and many products could belong to many orders. So this is what we call an anti-pattern in database design, or in other words, a big no-no. We don't want to do a many-to-many relationship. To solve for this, we have to create what is called a bridge table, or there are like 19 different words for what they call that table. But we basically break it out, and we call that order details. And so in this case, order details has 2 foreign keys in it. It has the order ID and the product ID. What this basically means is we may have multiple rows representing one order. In this situation, order 248, ending in 248, has 3 products associated with it. It has 11, 42, and 72, and we can see those details up in the products table. So the way that we solve for a many-to-many relationship is by using a bridge table. We say one order may have many order details, just like one product may belong to many different order details. So we basically take our many-to-many and split it up and say, hey, instead of many-to-many, we instead say one-to-many, many-to-one to get that data split. Kind of a weird concept, but think about it as basically saying, hey, we're going to break this out into a third table. That third table is going to keep track of the order ID and the product ID, but we won't be duplicating any of the data about the product name or the customer information. Any questions on that? Many-to-manys are very common. We just use that bridge table to bridge the gap between them, to split the many-to-many into a one-to-many and another many-to-one. Okay. One-to-one relationships are less common, but not totally unheard of. We normally don't have one-to-one relationships because when we do, we're able to merge the 2 tables down into the 1 table. However, if there's information that's infrequently collected about the item, sometimes it makes sense to store that data into another table. So a one-to-one table is something as simple as, hey, I have a customer and a customer is only ever allowed to have one address. But we don't need to access their address information very frequently. So maybe I have a users table and then I have an addresses table, and I'm able to say, hey, every customer or every user has one address, and if you need that information, it's often stored in another table. So we don't see one-to-one relationships very frequently, because one-to-one relationships can be merged down, all into one table. Okay, I think I'm largely done here. Refining the design. Once you think you've got a draft of your structure, start by loading in that dummy data, right? Go into a spreadsheet, start playing around with that, see if you have any design issues with it. You can always modify table structures to make your data more efficient. And then here's a checklist of, did you forget any columns? Is all of your data getting stored? Oftentimes it's easy to forget about an entire table, believe it or not. Are any of your columns unnecessary because they're calculated? Are you duplicating any information? Do you have the same information in two tables? Do you have any tables with a lot of columns and very few rows? If so, that table can probably be better architected. Is it broken down into the smallest parts? Does the column relate to the table subject name? Basically, did I put the column in the right table? And did I think about all of the relationships of, hey, we can access this data over from this table by doing a join. So when you have finished your ERDs, your entity relationship diagrams for the weekend, review this list and make sure you've kind of checked through everything on this list. That can be a good way to validate it before you send it over to me. Okay, so let's refine some duplicated data. What's wrong with this table? How do we solve it? Not a rhetorical question.
I don't want to be that guy and be like, oh well, I mean, there's a lot of ones, but
Product ID 2 is missing an entry.
That is one problem. What is another?
You can probably merge ID and user ID, right?
No, because how would I know? No, I can't, because user ID is not unique.
Oh.
And the other two IDs do not go up to 20.
The problem here is actually what happens if I want to place a third product on an order. Now I need another entirely separate column for that. Well, what if I want to place a fourth product onto an order, right? When I placed an order at Amazon, I've never gotten a message, you're spending too much money. No, they let me order as many things as I want in an order, right? So this database design isn't good, because theoretically, I would have to add a column every time the user wants to add another item to the order. Well, I don't want an artificial order limit size implied just because I'm doing that in a database. So here's how we solve that. We break that down into a bridge table. And this is what I was trying to say earlier. Now we have a table called orders, a table called products, and then we have order items. So we are going to create an order ID called 1. In order 1, we are ordering product 5 and product 2. Product 5 is shampoo and product 2 is soap. We now know that because these order IDs are the same, we are able to tell that those two products are associated. Well, what happens if I order another item? I'm able to still use order ID 1 and then use product ID 15 to add that item to the order. So we basically split this up into a one-to-many relationship between the order items and the products table. Does that make sense?
So what you're aiming for is rows are fine, but you want the least amount of columns possible.
Correct. Okay. Well, if that's the case, what are the rules here, right? Because all of this is like, all right, all of this stuff makes common sense. How do we actually apply this? Or how do I know if I make a DFD that that DFD is good database design? Well, there are 3 rules of normalization, right? Think about these as like Newton's laws, basically, for database design. Every row and column intersection exists a single value, never a list of values. That is a very complicated way to say that we cannot store arrays in databases, in relational SQL databases. Should clarify on that. So what we do instead is this bridge table. We break it out into a one-to-many relationship. Let's think about if we have a users table. Well, we may want to store all of the comments that user has made, but we're not going to throw that into a single column with an array with a list of all the comments they've made. No, instead, we're going to have a users table and a comments table. Every time the user makes a comment, we are going to store the comment text with the user ID. Now, every comment they create is a new row. If we want to get back all of those rows, we are able to say, take the users, join it with the comments table, and then we get all of the rows of all the comments they've made. So we are never supposed to store a list of values or an array in a single cell in the database, in a row column combination. Questions on that? Second, each non-key column is fully dependent on the primary key. What does that mean? Order ID, product name. Product name must be removed because it is only dependent on the product ID, not the order ID. So if we are making and this is very, very rare that this happens, this is why we just rely on the database to generate a number for us. But if we were to make a primary key other than the ID that got generated, we want to make sure that it is always unique. So an order ID will only ever have a product ID combined with it to make that unique. Compared to product name, there may be 2 products with the same name. So it's basically saying if you want to use a union primary key, if you want to make a primary key that's made from 2 different columns, you have to make sure that that data is always unique. TLDR on this, don't worry about the second normal form, because all you have to do is use an ID that the database generates for you, and you don't have to worry about the second normal form at all. So if that went way over your head, that's okay. Third normal form is not only every non-key column must be dependent on the entire primary key, but the non-key columns should be independent of each other. So if you use product ID, name, final price, and discount, you couldn't be able to update the discount without also updating the final price. So we broke a rule of normalization. What does that mean? This is basically saying don't store calculated values in the database. What this is trying to say is if you went in and you said, oh, I forgot, the customer doesn't get a 5% discount, they get a 10% discount. Well, now the total, the final price column in the database is inaccurate because we just updated their discount, but didn't update the final price. So how do we solve that? We just don't store final price in the database. We say, hey, if you ever want a final price of an order, we will recalculate that for you based off of all of the data stored in the database. So the third normal form, if you want to oversimplify it, is basically just don't store calculated values in the database. If you would like to overcomplicate it, it's saying we aren't allowed to store calculated things in the database because we could update one thing and not update another, and then we would have inaccurate data at some point in the database. Make sense?
I got questions. 2 questions.
No questions. I'm an
Just-
expert at teaching, and this stuff just makes sense.
Clarify for non-key column. That's just any other column that's not the primary key, like the ID.
Correct.
And this non-calculated things, whoop, is going over my head. So
Okay. So here's, the thing that always works for me with database design is just go into a spreadsheet, right? So let's say that we've got an orders table, and it's got an ID, it's got the customer ID, it's got the discount that was applied to the order, and it has the subtotal and the total. Yeah, we'll just say this. Subtotal actually causes problems because it would be calculated off another table, but for the sake of simplicity. So order ID 1, that's generated by the database. Customer number is 321. That's referencing another table somewhere. Because the person buying this is a teacher, they get a teacher discount. So that goes in as 5%. And they're placing a $100 order, right? Everything they bought adds up to that. So oh, you know what? Let's do this. Oh, well, I'll just leave this for now. The total of their order is $95, right? Because they got their 5% discount. Now I go back to the store and I go, well, I not only a teacher, I happen to be a veteran as well. I'm not, just so I get a 10% discount because I'm, have served. So now I go in and I go, oh, I need to update that row in the database. So I'm going to change your discount from 5 to 10. Well, now we just broke the third rule of normalization because this is no longer accurate. So what databases say is you shouldn't have the total column in here at all. What you should instead do is, instead of writing a query that says something like select total from orders, instead what we should do is we should say select the subtotal times the times, let's just store this as 0.1 to make it easier. It's 10%. Select the subtotal times 1 minus the discount from orders. So what's the difference between those two? Well, because I can update the discount amount, I shouldn't have a total amount. Now, if I go in here and change this discount, the second I run this second query, I'm going to get the accurate total number every single time. Compared to this, if I'm storing it in as I insert the row and I calculate the total, I don't want to ever store anything calculated. So the total is calculated. We shouldn't put that in the database. Instead, what we should do is do that calculation every time we pull the raw data that the calculation is based off of out. Does that help? It's one of those things that sounds really complicated until the light bulb goes off and you're like, okay, just don't store calculated values. I get it.
The total and the subtotal, it helped.
Cool.
Thank you.
Now, kind of a bad example because subtotal shouldn't be stored in the first place, right? Because you should be storing the item price and then calculating the subtotal based off of the item price. But for an off the cuff example, I'm glad that it got the click. Okay, any other questions on this stuff?
So when having an ID, that's going to like a different customer.
Correct. Yeah. So we would have like a customers table down here with an ID here, and we would say 321, 322, and then we could do things like first name, last name. And then this would be a primary key here. This is a primary key here. This is a foreign key here because this foreign key relates to this primary key.
So it's not possible to have the customer ID have like the same ID, or if they do have like the same number, is going according to just like one customer, or am I just like overthinking things?
Are you asking, can a customer place another order?
Yes.
So we would do that this way.
Oh.
So
Oh.
foreign keys do not have to be unique. Primary keys do.
I got it. I got it.
Any other questions?
Oh, I mean, I got like one other question, but it's more about like Canvas. I saw like the extra, like I guess the extra credit with the SQL Bowl. Like, is it kind of like free code camp in a way? Okay.
Yes,
Yeah. It's not required to do it, right? You're not required to do that. It's
correct.
just something. Okay.
Okay, we are going to dive in to an actual use case on this, right? Because I feel like a lot of this, you're like, all right, all of this makes sense. Still have no freaking idea how to design a database, right? I'm like, it's all common sense. How do I get started? And so I think a lot of that makes sense to anchor that in an actual use case. So let's go ahead and do attendance now. And the secret word is appliance. Appliance. Because what we are going to do next is kind of like when I made you design the car screen all the way back in week 1. We are going to do that thinking through the requirements of a database for an appliance repair shop. That will probably take us through to the rest of class. We will get into doing the actual the actual ERD design tomorrow. Appliance, yes, Terry, is the secret word. You got it. So we are going to kind of think through all of the requirements of a repair shop. I'm going to show you what a data flow diagram looks like. And then we will actually design the database based off of the requirements that we have gathered. And And I oddly don't remember doing this last cohort. So I think I had a sick day and they just missed out on a day of this. Okay, let's go ahead and dive in. I will share this document with you guys. That is in the chat. So we're going to start this by saying appliance case requirements.
Max,
Yep.
sorry, you might need to change like the
Oh,
share.
the view
Yeah.
permissions.
Yeah.
Thank you. There you go. Just refresh and you should be good to go. Thanks for that reminder. Okay, so we're going to start by saying a man walks into a bar. No, just kidding. A customer walks into an appliance shop. What has to happen? The appliance shop owner has come to you and says, I'm sick of it. I'm not going to do it on paper anymore. I would like an app that does all of this for me. What do we need to think through in that app? Not the UI design in particular, but what are all of the things we think needs to happen for a appliance shop to have a web application they can use to run their business more efficiently?
To have different, like, I guess, categories of what part they need, I suppose.
Yeah, so we need to do part management. Customer info.
Employee or clerk info.
Yep.
What about the product?
Yep, we're gonna call those appliance database. We need the part management, I'm gonna say, and prices there. Because this is just a repair shop. They're not selling any appliances.
Sales dashboard. Are you talking
Um,
about non-UI things just from the database perspective?
yeah, we'll say that sales is not part of MVP. We're just looking at tracking. But yes, in general, that would be a good thing to add. What happens if we have a customer and they come in and they say, I have this toaster oven and I want you to fix it? Well, how do we know that the appliance shop has the toaster oven? What would that fall under?
Transaction log.
Transaction log, I'm going to call it a service order, right? Because when that comes in, we need to create a new thing for them. That toaster oven may have been here 3 times already because it was made in America and nothing made in America is quality anymore, right? So it could be a situation where we have to keep track of that item every single time that it comes in. Okay, so we got our customer info, we got employee info, we've got a database of all the different appliances that exist, and then we've got all of the parts associated with it. Pretty good. Now, let's talk about data flow a little bit, because oftentimes we want to dive into structuring this data right away. But we want to think about this in terms of the business, in terms of how this actually operates. There is a process flow or workflow that the business has probably been using for 100 years, but no one's ever thought to write that down. How do we often get that information? You get it on training. On your first day, someone just tells you how everything works, but no one has taken the time to actually write that process down. So as developers, I'm telling you, the reason why I've been so successful in my career is because I'm not afraid to say, can someone write that process down for me so we can look at it? Because now all of a sudden, another team member goes non-technical and they go, oh, well, I actually do X, Y, and Z, and that's not part of the process that you came up with. So now they add that in. Now another person goes, oh yeah, but what you didn't think of is who this gets handed off to, who takes this on after you. So oftentimes a business can be optimized not only with technology, but also looking at the processes themselves. The best way to do that is to create what we call an as-is diagram, right? Or as-is documentation. Before this software comes in and revolutionizes this appliance shop, we need to think through what are the processes of a appliance shop. So I like to start at the customer. A customer walks into the door. They're standing at the front counter with their broken toaster oven in their hands. What do you think happens in the appliance shop to kick off the whole process?
They ask the person what's wrong with the toaster.
Yep. So they're gonna say, "Hi, you're dropping off your toaster. I need to log this information somewhere." So we're gonna group that all under create a service order. And in that service order, they're going to capture what's wrong with the appliance. What else are they going to do?
Probably expect the toaster. I suppose they gotta actually like look and see like what parts do they need.
Yeah, so they're going to say look up if appliance is already in the database or create it if it's not. And then same for we're gonna say the person creating the service order is just the front desk person, right? They're not trained in the actual appliance. So the part's gonna matter, but not yet. So keep that idea in the back of your head, just because the person repairing it is probably someone different. And I'm really glad you brought that up. When we are looking at roles, roles don't just apply to what can they do in the software, roles also apply to businesses as well. Hey, are you an administrator, or are you a customer service agent, or are you the developer, or are you a manager who needs reports? We want to identify all of that as part of the process flow so that when we build our software out, that's all part of it. So they looked up the appliance, they created in the database. If it isn't there, they got the information of what's wrong with it. What are the other two things they probably also need to do before the customer can leave?
Customer name and contact info.
Yep. They need to look up existing client or create new I shouldn't say client, I should say customer. Or create new customer with all their info. And what's the last thing you do before you walk out of dropping off your dry cleaning?
Get some sort of receipt.
Yep, exactly. All right. Feeling pretty good about that. The customer has walked in. We got the information about the appliance. We got the information about them, and we generated a receipt for that. Any questions about that step? Okay, so now we move on. We say, okay, the customer's out the door, and the last step in creating the service order is assigning that service order to a technician, right? So the person pulls up a chart, they've got 3 technicians working. and one dude is completely slacking off and has nothing assigned to him. And so the front desk person assigns the service order to an available technician. Okay, now we move into the next step of the repair of someone else's role now takes over. So this is a new process. This is the estimate process, right? Because we never take our car into the mechanic, and when we go to pick it up, they go, "That will be $4,000, please." And well, sometimes they do. And you go, "What? I just wanted an oil change." Well, no, if they needed to do $4,000 of work, they're going to call you first and go, "Oh, by the way, so much needs to be done other than your oil change. Would you like to do it now?" So let's think through a little bit of those steps. The estimate is going to start with the repair technician opening a service order, opening up the service order by filtering down by filtering by status, right? Because every service order makes sense, has a status, right? We drop off our dry cleaning, it's going to be, say, it's dropped off, it was shipped to the facility, it was scanned in at the facility, it got cleaned, it's waiting at the facility to come back to the drop-off point, the drop-off point has it, they contacted the customer has now come back in and got it. Same thing goes for our appliance, right? We're going to go through a similar cycle. So the repair technician figures out which one he's working on, pops it up, reads the reads the details of what's wrong with it, and now they go, all right, we need to do what? Now that we've looked at it, we've diagnosed it, what should we do next?
They need to look up like the part that it needs to see how much it is.
So they look up the parts, they go, all right, that's how much it's going to be. They also estimate the enter time estimate for the service order, right? And they go, all right, we're $100 an hour. We got the parts in there. What's next? Approval. Yeah, they got to contact the customer and tell them estimate details. Now, we could get in a more detailed process flow would say, well, how do you contact the customer? Are you sending them an email for approval? Is the system new enough to send out a text message where they can respond with a Y or an N if they approve it? Are we old school and do we call the customer? But no matter how we're contacting the customer, we tell them the estimate details, and then we need to update the status as well, right? Because we need to say we contacted the customer and they didn't pick up. We need to say we contacted the customer and they approved it. We contacted the customer and they said that's ridiculously expensive. Give me a couple days to think it over, right? We always want to be logging every interaction that we have either with the appliance or with the customer. Because what happens if I get sick and all of my appliances need to go to someone else to get them repaired? Well, we always want to be tracking the progress of every time that we're interacting, so that someone else can step in and help out. I have spent 3 hours on the phone trying to get an update on an insurance claim for my health insurance, because they messed up and filed the claim as out of network instead of in-network doctor. Well, I have now had to call back in every 3 days and say, what's the status of this? What's the status of this? Because I get a different customer service agent every time that I call in. So those are things that we want to capture. Now, you guys may be thinking, well, this is super boring, but as developers, oftentimes these processes are not well thought through. So we want to really be able to dive into them and almost be a consultant to say, hey, let's get your processes figured out first before we develop an entire application around it. So they contact the customer, they get the approval, then they are going to update service order with dates, right? Like the estimate of when ready. They already looked up the parts and added them to the service order. They are going to do the repair. And then we're a minute before break. Hold your horses. I had the eye on the time. I did get my time back, by the way, so thank you for reminding me. Then they're going to change the status for ready to pick up. And finally, something that we probably wouldn't normally think of, we need to log the hours of this, right? Because the employee may be paid hourly. We need to generate the hours of that they actually worked on it. Oh, they estimated 3 hours. It only took them 2 hours to actually repair it. So we're going to log hours of repair. Log time of hours to repair. Estimate and repair. Okay. We are going to, well, I lied. Give me 2 more minutes so we can just finish this step. Final thing we need to do, other than estimate and repair, what's the last step of the entire process?
Repair.
Well, after the repair is done, what's the final step?
Collect money.
Give it back.
Yep. Pick up. So the customer walks in. Oh, I guess the last step we should say here is contact customer, repair is done. Customer walks in for pickup, front desk filters appliances for what's ready for pickup. They log the payment info and change status to picked up, and we are good to go. Literally good to go on break. So go on break, be back at 7:26 because I went a minute over. When we get back, we will take a look at data flow diagrams and then start working on our entity relationship diagram. All right, so we are going to dive into making our first ERD tonight, our entity relationship diagram, which is basically just a diagram that's planning out our database, right? But I do want to just wrap up the notion of processes, right? And so if you guys think about your jobs, there's a lot, or jobs you've worked in the past, there are probably a lot of processes that are done that you just learned about because someone told you to do them, right? So hopefully this is a step that you can go back to at some point when you're starting a new job and someone's trying to tell you what to do and you're like, well, where's this documented? Where's the process for this? What happens if someone is out sick during this process? Getting those processes documented are a really, really important thing. Is anyone else having trouble hearing me? Okay, just you, Joe. Sorry. Check file provider D, see if that's spiking. Just kidding. Process documentation is a really helpful thing to do. And so I'm going to just show you guys what a data flow diagram is. This is the notion of how does data flow through a process, right? So we represent a function by a circle. That's basically saying what is getting accomplished. we use these like a rectangle without sides on it to say that is where information is stored or retrieved from. The box is input or output, right? So where does this ultimately end up? And then the arrow is really important because flows usually only flow in one direction, or if they flow in two directions, we want to be able to label that flow of, okay, what data in particular is flowing, right? So the very first step here is creating the service or the repair order. Well, the customer is the input here. They're the ones providing the data of, what needs to be repaired. So we capture the customer and appliance info that goes into the process. What comes out of the process, well, the customer info goes into the customer's data store. That's going to be the file cabinet with all the customers. And then the appliance info is going to get stored over in the service orders, right? So this is less thinking about the database in particular, and more about thinking about, in general, what information is going where. And then, of course, the result of the service order is that the receipt gets generated for the customer. The rest of these are pretty self-explanatory. When we assign a technician, there's a database or some kind of table with all the technicians. We get the technician number, so we know what to assign to that. We take that technician info and we save that into the service orders. When we do the estimate or repair, we start by taking the repair info into the service orders. We take the parts used, we pull the appliance info out, we send that repair cost to the customer gives approval, and we're ready to move on to the next step. So a lot of these are, again, self-explanatory, but if you don't have them documented, there's no way to say, hey, on your first day, here's how this business works in general, right? Then if we come down, the picking up of the appliance, we get the repair info from the service orders, we get the customer payment info goes into that process. There may be some third party here, so that is again listed as an input or output. In this case, it's the credit card verification. We get the response, we log that information, and we provide it to the customer on a payment receipt. Okay. Almost scrolled too far. That's going to be the answer for everything that we start working for on our ERD. So these are basic data flow diagrams. You can see that they are helpful in terms of, instead of writing everything out as bullets or a sentence, oftentimes a diagram is a much better way of representing some information. So if you're ever working with a client and you feel like the communication's kind of breaking down, lots of different things that can be causing that, right? It could be a delay in, hey, it takes 2 or 3 days to hear back from you every time. That's causing problems. It could be that, and this is a real concern for me in our society, is people don't read anymore. So you send an email that asks 5 different questions in it. It's detailed, but also succinct. And you get an answer back and it's yes. And you're like, I asked you 5 questions. Yes to what? Drives me insane, right? So little tricks that you can do there of in your email, bold out the question, or get better at only asking 1 question at a time and having 5 emails queued up. So when you get the first one back, you can send another one. Oftentimes, email is just not a good method of communication for some people, right? So sometimes it's much better to say, all right, let's sit down, let's schedule a standing meeting every week. Let's meet Friday at 9 a.m. and we're just going to do 30 minutes together summarizing everything that's gotten done, right? So lots of ways that you can approach communication. The reason that I'm bringing that up, though, is these technical concepts oftentimes are better as a diagram, right? Something like this is much easier to look at and understand a general data flow compared to a bulleted list of all of the information up here, right? So that was actually from cohort 4, this list up here, right? So think about that when you are communicating something technical. Oftentimes you can just go to a whiteboard and draw it out for someone, or what we're going to get into next, which is drawio.com. is a great way of doing this flow charting. So this is kind of like Figma. It is a design tool. However, it is specifically for diagramming with lines on it. A couple other options here. I have loved OmniGraffle for a very long time. That is a downloaded Mac version for creating flowcharts and diagrams. It's a little bit more powerful than Draw.io, and it feels a little bit more Apple-ish. Feels a little bit better polished than Draw.io. It is not free, however. So that's the only reason why we don't show that in class. Their Draw.io used to be called diagrams.net, and then they changed it back to drawio.com. There was also another one called Lucid Chart. Lucid Chart is very similar to Draw.io. I believe it was forked off the same open source project. So just want to throw a couple alternatives out there for you guys to look into so you know that they exist. But anyway, diagramming tools are your friends as developers. It's very often that we have to communicate with non-technical people. And so having a diagramming tool to lay all of that out can really go far. You know, they say a picture's worth a thousand words. Well, what's a picture with lines and words on it itself worth? 2,000? But that's basically what a diagram is. So lots of different diagram types. If you guys head to draw.io, you are welcome to follow along with me on this. I would recommend that you do so that you get a little bit of practice creating the different shape types that we're going to be working with, because your homework assignment that is due at the end of the weekend will be creating an ERD. One final reminder, you don't have to create an ERD in Draw.io. If there is some other diagramming or flowchart software that you like and you use, there is a 95% chance that it has a template for ERDs, entity relationship diagrams, that you can use in it. Terry, you had a question before we dive into the ERD.
Yeah, this is regarding to the thing I sent you like earlier. Is that right? I did it because I used I think Lucid. Yeah, I used Lucid.
Lucid Chart
Yeah.
or Lucid? Oh no, Lucid and Lucid Chart I think are actually different companies. Oh no. Well, Lucid now has 3 different diagrams. Oh, they've changed all of this. Interesting. Using Lucid Chart is totally fine. Lucid Chart and Draw.io used to be very similar. It seems like Lucid woke up and realized they needed to get into the 21st century. And so it looks like they have added some additional features. So the general like the shapes you use and how the lines connected, that was correct. The layout of the data is not entirely correct. But if you are like, this is all I can do, I'm ready for feedback on it, submit that in Canvas, and I will spend time early next week reviewing all of your ERDs and making corrections to them, along with explanations as to why it would be better to structure them that way. Okay. Any other questions before we dive in? See, I'm not crazy. Once you are on drawio.com, it takes you to diagrams.net. These guys are having an identity crisis and can't figure out what their name is.
Yeah, it's the same thing for like Lucid Chart. Like I think it's Lucid.app. Like it's just so weird.
Okay, so if you are on Draw.io, I'm going to hit the start button. If you want to download it, you can. It's totally fine to do in the web browser. I'm going to hit create new diagram. And then I am going to scroll down here and select my ERD, my entity relationship diagram. And that's just going to pull up the right templates for me. And then finally, I want to make sure that I name this, right? So I'm going to name this appliance case ERD. And then I'm going to go ahead and hit create. That will bring me into my files. Make sure you save this somewhere you can find it, because chances are you're going to want to be able to go back to this, make edits to it, all of that kind of stuff. You know what, before I forget, I just want to make sure I allow different file types in that assignment. Yes, I do. So you can upload a PNG of your ERD. You can upload this .drawio file directly, however you would like to send it to me. I will find a way to get it open. So that is totally fine. And I just noticed there's one other. There's another homework assignment in here that I don't know if it's actually going to be due, so I'm going to unpublish it so you don't have to worry about that one. Okay. So I'm going to go ahead and save that file. That should bring me into here. It starts me out with customers, orders, and shipments, which is, I guess, fine to start with, but not what I want to be working with directly to get started. So I'm going to kind of draw a box around all of them and just hit the delete button, and that will start me out with an empty canvas. Okay, what did I say we often start with in our ERDs? We got this blank canvas. It's the equivalent of a blanking cursor in a white document in Word. Where do we get started with an ERD? Think back to the slides. What did I say was a good starting point?
The list of columns.
Before even we do the columns, where do the columns need to go into? Tables, right? So we are going to look, and the place that I like to start are sometimes the biggest or the most used tables. So looking at everything that we have in this document, right, where we're thinking through the flows and all of that, what are probably the 3 tables that we are going to use the most, or the biggest tables, or the ones that we're going to be constantly going back to?
Well, create service order.
Service orders, yep.
Estimate repairs. No.
Well, the estimate is probably going to be on the service order itself.
So
Pickup?
definitely pickup.
Pickup, but those details are going to be on the service order as well.
The appliance case requirements, because you plan on getting multiple new customers every day.
Oh, yeah.
So service orders, customers, and
Do we need something for like
Appliance
the,
case
let's
requirement.
say parts or appliances. Those are all, yep, all good answers. So let's start with those. So I'm going to come over here and I'm going to grab this. It's called, hold on, before I tell you to do it, let me make sure this is the one that I want. Nope, see, I knew I was wrong. We are going to come over, expand out entity relationship over on the left. If you don't have this sidebar, you may need to go up here and turn on shapes. And then over on the left, entity relationship. And I'm going to go down and I'm going to grab that second one out. And if I click on it, it will insert it, or I can click and drag it over and put it where I want it. So we're going to start with our service orders. And we should do some hygiene here. We said almost every table gets an ID as a primary key, right? Just easier for the database to generate that out. So I'm going to double click on my row 1 and I'm going to say ID. I am then going to go over here and just mark that as my PK, my primary key. Now, I don't have anything else that needs to go up here. So if I go over to arrange over here on the right, and again, you may need to pop this little sidebar out from the icon in the top right, you'll see that there are all of these buttons for the table. This is the easiest way to add or remove rows. So if I just click on row 2 and have that selected, I can hit that last icon there and it will go ahead and remove that row for me. The same goes for adding rows. So if I select that entire table and click on the button to the left of what we just clicked on, we're able to add in multiple rows, and that's what gives me text boxes that I can work with. So sidebar, click on the table, you get the Arrange tab up at the top, and then Add Rows is the second to last button, and then Remove Row is the last button there. Does anyone not have that?
I'm not seeing it.
Up in the, do you have your table selected?
Yes, sir.
Do you see Arrange in the top right, or is this entire sidebar missing?
Oh, found it.
Beautiful.
I bet.
It's very tempting to just like do a new line here and like keep on adding into one text box. Not recommended that you do that. So if you click on the table and go to arrange, these buttons I have personally found are the easiest way to do it. There are other ways, like if you right click, I think there's an add row, but I have found that these buttons on the right are the easiest way to get started. Okay, so we said service orders. I'm also going to grab another table out, and we don't need to grab we could go to the right and drag that table out, or I could come over here and Command D. That will duplicate my table. And then I'm able to say customers up here at the top and add that in as well. Okay, we also said that we're going to need a parts and an appliances. Switch the wrong tabs here. Okay, so let's start working on those tables. So I'm going to try and leave this over here. We got the basic requirements up here, right? We'll circle back to those, make sure that we're able to hit all of those. But when we look at something like create service order, this is a workflow. This isn't necessarily capturing all of the data that is used inside of that workflow. So we now need to dive into this and say, out of all of these steps, what data is captured in those steps? 1, and 2, what table should they get stored in? And then 3, what are the relationships between those tables? Because if we're capturing this all in one workflow, chances are we're going to want to be able to write one query that does a join on a table to get all of the data back out so that we could show it to an end user, even if that data is scattered across multiple tables. So I'm looking at my appliances here, and I'm going to close some of these sidebars just so, oh, I thought I was going to. I'll hide this one, skirt this one over here. I could swear there was a way to hide that, but now I'm going crazy. There it is. Okay. So what's the very first thing that we said in the service order? What's wrong with it? So we're going to go into our service orders, and we're going to say problem explanation. And now we want to think about data types. And there are 2 ways of doing data types. Traditionally, in ERD diagrams, there's a third column here that we're able to add in that data type. You can either do a comma here and do the data type right after it, or you can use this column over on the left and do the data type in there. The data type on the left isn't the traditional place to put it, but I do think that it makes reading the diagram a little bit easier. So problem explanation. We have two data types that we can use for strings. One is a varchar, which is 255 characters, but sometimes you get a customer who comes in and goes, it's making this noise, and I think this is wrong with it, and all of a sudden you're over 255 characters. So I'm going to say that that is going to be a text column. Now we can start thinking about some other fields that are going to come in here. So something like, hey, we want to keep track of the date of drop off. Date dropped off. That is going to be a date data type. Now we also have said, hey, we need to look up if the appliance is already in the database or create it if it's not. Okay, well, that's the process, right? That isn't necessarily the data that we're capturing from that process. So if I come over, I have my appliances table up here. If you hold in space, you can click and drag the canvas around, or you can just scroll up and down, obviously, with on the trackpad with two fingers. Or if you have a Logitech MX Master, you can use the fancy horizontal scroll wheel now. Okay, so appliances, we got the ID in there. Now let's think about, well, what do we keep track of in the appliances itself? Well, this is actually probably pretty easy. We probably have a make of it, which we are going to make a varchar. We have a model of the appliance, which will also be a varchar. And let's add one more. Maybe we've got notes on that appliance. And let's make that a text, right? Because, I don't know, one model may come in all the time and a technician may want to log that information of, oh, this model, this part breaks all the time or whatever. Well, now we run into something interesting. This service order needs to have an appliance connected to it. So what we are going to do is add in an appliance ID to our service orders table. Now that we've got our appliance ID created, we can go over, and if we hover over this, you see that there's a really faint blue arrow there. If we move our mouse over to that blue arrow, it darkens and gives me a little plus icon. I'm going to click and drag that all the way up until my PK ID up on the appliance table shows up. Let me do that one more time. I'm going to hover over the row. I get a little blue arrow. I put my mouse on the blue arrow and drag that arrow up to my ID and let go. Now, a proper entity relationship diagram uses this stupid thing called crow's feet, which is meant to show you if the relationship of the data is a one-to-many or a one-to-one. I've never in my entire life needed to know what kind of relationship it was that I couldn't just figure out by looking at the diagram. So if you showed this to someone who is like a database engineer, they would scoff at you and be like, this isn't a true ERD. It doesn't have the relationship data in it. I'm not even going to bother teaching you the relationship data because it's pretty clear that the appliance ID here is connected to the appliance up here. That's all that really matters. There is also some debate of should you camel case a column name in SQL or should you underscore it? And then there's also always a big debate of is ID capital I lowercase d or capital I capital D, or is it an underscore and you keep it all lowercase? There's no like official answer from SQL there as long as you are consistent. So just a couple things that I wanna throw out there. But if you are curious on like proper entity relationship diagrams, you can look up what is called crow's feet. And that is basically a little symbol that they put on the line here so you know what kind of relationship it is to the appliances table up here. Okay, believe it or not, our appliances table is now already done. There's obviously more info to add to the service orders, but let's get some practice with the customers table. The service orders not only has an appliance ID, it also is related to a customer. So I'm going to go back into my sidebar. I'm going to add a row down at the bottom, and I'm going to say customer ID. And I already made a mistake because this has a line connecting it. Because we know the appliance ID is a reference to the primary key in the appliances table, I can go ahead and label that as a foreign key, an FK. Same goes for this customer ID. That will be a foreign key. And all of our keys, because they are generated by the database, will actually be integers. So you could also say like FK comma INT if you wanted to, but we're just getting the general concept here of laying out the database, understanding how they all connect. So I'm going to go to my customer ID here. I'm going to grab that arrow and I'm going to drag it up to the primary key ID up here at the top. So now I've got my two tables connected. I know the appliance ID is referencing the ID. I know the customer ID is referencing the customer's table primary key over there.
And
Okay.
the foreign
Oh,
key,
go ahead.
they call it that because the key originates in a different table.
Correct. It's foreign to the primary key in another table. It's foreign in this table. It's primary in this table. And this is a good example. We can have multiple foreign keys in a table that can relate to entirely separate different tables as well. I have had tables that have had up to 10 or 15 foreign keys in them because the data was so relational. So that's a very common thing. Okay. Now we get into something interesting. These parts, let's think about what would be in the parts table. Probably some kind of description of the part. And we'll say that's a varchar, right? Because how long can a part description really be? Let's say that there's a cost associated with each one of them, and we're going to make that a float, which is like a double or a decimal number. And then the last thing we probably need to keep track of is, let's say, quantity in stock. And that can be an integer, because we won't ever have a decimal of that part in stock. So let's just take a second here and think through what this would look like so far in a spreadsheet. And this is where I'm going to come back to bridge tables, because that is something that can be a hard concept to understand, right? So let me make a new tab here. We're going to say, hey, we've got our service orders, and that has an ID, the problem explanation, the date dropped off, the appliance ID, and the customer ID. And we'll say, now we know appliance ID, customer ID, no problem. Those are referencing another table. So it may be tempting to come in here and say now, well, pause. Does anyone have questions on how this ERD rectangle relates to this, which is how it will ultimately look in the database? Kind of see the diagram. We can kind of see the benefit of practicing with that data. We can also see the benefit of the diagram itself, which is identifying the columns, their types, and the relations between them. Okay, cool. So now we come in here and we set up a parts table. And what did we just say? A parts table has an ID, description, a cost, and quantity remaining. So we'll say part ID 1, and I don't know, it's a heating element. It costs $100, and we've got 2 of them in stock. We've got a thermostat, which only costs $25, and we got 5 of them. And we've got a compressor, and they're $500, and we don't have any of them in stock. Oh, let's say we have 1 in stock. Okay, now I need to keep track of what parts were used on my service order 1. I could theoretically come over here and add a parts used list and say, hey, I needed to replace 1 and 2. What rule of normalization did I just break?
Make the keys, they're supposed to be independent.
They're supposed to be independent. We're not allowed to store list or array values. Why not? Well, I could come in here and go, oh, for service ID 1, I want a list of all the parts that were used. So what I'm going to do is I say select the service orders problem explanation, and also select the parts used from service orders. And I want to join my parts table on, and now I'm like, all right, my parts.id is equal to, and now I'm like, shit. I can't tie it to parts used here because parts used here is 1, 2. How does SQL know that I want both of those in there? It doesn't. We can't do on service orders dot parts used because this has multiple values in it. That's a no-no. So here's what we have to do instead. We're going to create another table called parts used, and every table gets an ID. So we'll throw an ID in there. And we're going to keep track of 2 pieces of information here. We're going to keep track of the service order ID. And we're also going to keep track of the part ID. Now, the service order is 1 on both of them, but the part ID will be 1 and 2. We are then able to write a join query that is able to say, hey, service order ID 1 is going to link to this whole row right here. The part ID 1 and 2 is going to link to this row here and this row here. Now I can write a query down here that is going to say join parts used on the service order ID matching and join on parts where parts used matches the part ID. Let's end on that note. So I'm going to update my table because I don't want to link a part ID specifically into my service order, because many parts can be used on many service orders, and many service orders may use many parts. That's what we call a many-to-many relationship, and we want to avoid those many-to-many relationships whenever we can. So here's how we fix that. I'm going to create a new table. I'm going to call it parts used. I said I'm going to keep track of two things. One is the service order ID, and the other is the part ID. We'll go back in and delete that last row out. And then I'm going to link my service order ID up to the ID on my services order table. And I'm going to link my part ID to the ID on my parts table. That is what is called a bridge table or an association table or a many-to-many table. It has so many freaking names that I went to ChatGPT and I said, what's the name of a many-to-many table? And they gave me a list of about 15 things they called it. So apparently no one can agree on what the name of this table is, other than it is a table type that is used a lot for that. So this now looks a little ugly with these lines coming out. So you can always rearrange your tables, right? So that they line up a little bit better. Or you could even put the parts up here. And I could take this line. And if I remove it and redraw it on... Eee, what did I just do? Parts used. That's all linked properly. Customers. Oh, it's linked to customer ID. Okay, so let me try and put my parts used up here. My parts further over.
Is there like any way to like change like the lines like connected to each other to like a different color?
Yeah, you definitely can. If you select the line up at the top, there's like the paint bucket, and then to the right of that, you can change that to any color and hit apply, and that will change the line. I've never actually seen an ERD use color, but I kind of like that idea, so feel free to do so. So I still don't like it over there, so can I grab this? No, I'm just going to redraw it. Service order ID goes to the ID over here. It's a little bit better. And we'll move our parts over and down here. So the order or the layout of this doesn't really matter. You just want to make it readable. And there is like an arrange up here. So if you select everything and hit arrange, there may be like an auto layout. I forget how you do that. But anyway, layout doesn't matter too much as long as it's readable. So, any questions on your ERDs? Do you think that you've got a good starting point for doing your homework assignment this weekend?
Yeah, but I do need more practice. I could like practice on my own time, but I think we could talk about it a little bit tomorrow.
Yeah, so I'm going to give you guys the rest of class back. If you want to get started on your ERDs now, I would encourage you to do so, because you'll be able to get a couple tables created. And here's the beauty of your capstones. You may only have 2 tables, and that's totally fine. Normally you have at least 2, because you have like users and then the data tied to that user. Or your capstone may have 20 tables in it with all kinds of crazy relationships. So I don't mean to overwhelm you guys, but this is the actual final ERD of the appliance case. And so this covers a little bit more data. This has keeping track of problems, right? So that if a very common problem occurs, like, oh, the compressor died on this refrigerator, you're able to track how frequently that happens. This is breaking down the repair statuses a little bit more so that, again, those repair statuses are reusable. Are we waiting to hear back from the customer? Has the estimate been approved? Are we waiting on parts to come in? All of that kind of stuff. It's handling the users on service order like a bridge table. So multiple users could be tied to a service order. Who checked this in at the front desk? Who was the technician who did the estimate? Who was the technician who did the actual repair? We're keeping track of payment type over here. So instead of just logging it as a text string, we're keeping track of that. So for data analytics wise, we could come back in and say, hey, American Express is charging us more on fees. Let's identify how often we actually take American Express. You can see we do have the bridge table over here, just like we did. But for the most part, this gives you an idea of all of the data and how complicated the service orders table can get, but how those all can interlink with each other. So your ERD could be this advanced. It could be a third or a quarter of the size. That is also okay. So tomorrow, we are actually going to start our first full stack application. However, we'll start class with any questions you may have on your ERDs. I'm going to do a poll right now before you guys get out of here on if you guys want to do office hours and when. So we'll do questions for ERDs starting class tomorrow. We will install our first database or our primary database, the one we'll be using called Postgres. We'll run our first SQL commands on that database. Then we will set up our to-do list application and our first real API using something called Express. And that to-do list app will take us definitely into Monday as well. So I don't want to overwhelm you. We're going to go step by step on this. And just like our React projects or our vanilla JavaScript projects, it's one of those things, the beginning is always very daunting, but we've got 3 full weeks of full stack where we're going to be doing project after project after project of setting up the API, connecting it to the database, creating our tables, all of those steps. So it will be something that is going to feel overwhelming to get started, but then will feel a lot better as we keep on practicing and doing it over and over again. You know what? I'll just do the office hours poll. No, let me do it now. Sorry, I'm being indecisive. Okay, go ahead and vote for office hours. Totally optional. And you can vote for multiple times if multiple ones work for you.
Well, I don't think that's a fair
They will be, I will be at Common Space downtown, but then also open the Zoom room as well for anyone who can only attend virtually. Sorry, I should have specified that.
Is there a way to add like another column on here? No.
I don't think so. Oh, you know what? I think there is. Yes, there is. If you click on the table and go to arrange over on the right, just like we have row buttons here, we have columns over here. So it's the second one over, and that will add a column on the right. And then you can also resize these columns as well. Okay. Office hours looks like Sunday at 1. Thank you to all 3 people who got enough of me. I got enough of you guys as well. For everyone else, I will see you Sunday, 1 p.m. at Common Space. I will also have the Zoom meeting open, and it will be in the regular classroom link for that. And as always, no topic for office hours. Capstone's fine. ERD advice is fine. Any of that is totally fine. The spreadsheet with the appliance ERD. You mean this one? Yeah. And I'm gonna just hide that one. And that is, I'll throw it in Zoom or in Slack. Well, I'll put it in Zoom too in case anyone wants it there as well. Okay. I will stick around if anyone has ERD questions or would like to work on their ERD and get some initial feedback. And totally no hard feelings on anyone who voted the I won't show up. I totally optional. I totally get it. I'm gonna put that in my calendar before I forget. And then if anyone needs help with diagrams.net or draw.io or whatever the freak they call it, happy to help you now. Otherwise, have a great evening, and I will see you guys all tomorrow for Get Excited, our first full stack application.
So like for the primary key, we need to put them to the right. Like when we like write it, like I know you mentioned like with like text and date and bar card, we need to put it to like the right of the column.
Yeah, so traditional ERDs that I have seen look like this. So you would do varchar and not have it here, basically. And then what that allows you to do, like for this one, it would traditionally, what I have seen is this. So this is like the most correct out of all of them. Because and then of course you can always like resize these columns, right? So it isn't quite as huge. So that's probably how I would do it.
So you want to put anything on like the far left one column?
Not for these two, because they're not a primary key or foreign key.
So just to confirm, we just need this diagram, correct?
Yes, for your capstone.
Gotcha. Okay, we don't need like the accompanying
SQL for
like
it.
Google Doc or something like that.
Oh, no,
Right.
no Google Doc. If you would like to do that step of, hey, I think my diagram is right, let me create a Google Doc and start putting in dummy data and making sure like the data looks right, that is a good verification step for yourself. but the only thing you need to turn in is the diagram itself. And as
Does it
far as
matter
I
where
know, none of you are creating an appliance repair shop software for your capstone, so. But the reason why we do this is so that you get a leg up on, hey, let me properly think through my database diagram, because Khan Academy leads you on to thinking like, oh, I'm just working with 2 tables, and then you realize that you're 20 tables in and not storing data properly.
Yeah, I found I have some pretty good tables on mine.
I'm going to open your ERD and my computer's just going to burst into flames.
Yeah. What did I do?
Um,
Do you save yours to Google Drive, GitHub? Does it matter? Device?
doesn't matter. Wherever you'll be able to find it again. I'm trying to see if I have a real world ERD.
Either basic and entity relationship diagram.